There was one particular piece of math that was missing. I could not, for the life of me, fathom how I was going to make this particular transformation. It's something that I had been ruminating on for probably weeks, painfully so. You know, to where you wake up in the middle of the night in a cold sweat because you don't know the answer yet. Well, one night I woke up in a cold sweat with the answer, jumped out of bed, wrote it down, and then got up the next morning and realized that it wasn't doggerel. It was actually the solution, and it now is utilized in the system that we have today. But it came out of a dream.
Do you ever wonder how a simple dream could maybe lead to great technological breakthroughs? Well, we will hear a story about that from our guest today, Russ Young, Chief Technology Officer here at Hach. Welcome to Testing the Waters. I'm your host, Stacy Flax. Russ.
Stacy.
How are ya?
I'm really good, thank you.
Good. Good to see you too. Thank you so much for coming on today. Let's talk a little bit about who is Russ Young, Chief Technology Officer here at Hach. Who are you?
Who am I? Okay. First off, I'm the what I call the head nerd of the company, and I'm blessed with the fact that I get to oversee the development of research projects at Hach Company. I actually am working with the lead scientists and lead engineers. We have everything up to and including distinguished scientists, principal scientists, senior scientists within the organization. I myself am a bioanalytical chemist and biophysicist. That's what my PhD is in. I went to school for chemistry and then moved into graduate school and got my PhD, as I just mentioned, at Colorado State University. And then I immediately, after my postdoctoral fellowship in reproductive and immunological physiology, I did a stint in postdoc, and then I came to Hach directly.
Nice. So let's talk about the focus. So you've talked about your career, your education, and then let's talk a little bit about your career, where you got started, where your focuses were. And then also, was there a point ever that you were maybe thinking about shifting your focus?
Actually, I went in high school. I was fortunate enough to go to a high school that actually had an excellent science and math program. So I'm a big proponent of STEM, and it's partly because I had an excellent experience. And I came out of high school with essentially a major in chemistry, a major in physics, and a major in math. So we had multiple chemistry classes and multiple physics classes and biology. And so I came out of school with this great package from which to pick, right? So eventually I would take all of them and put them all into one package. But at first when I went to college, I was going for physics. But my university at the time, Alfred University in upstate New York, they really weren't equipped to move me along in the way that I needed to really make a splash in physics. They did have a fine chemistry program. And so I actually had majors in both. And so I actually pursued a chemistry major in earnest with a biology minor. And obviously the math that was a component of, that was necessary for both. And so I made my first switch from physics to chemistry. And then when I went to graduate school, I actually was looking at the chemistry department at both CSU, Colorado State University, and Syracuse University. And both were, interestingly enough, both had very fine programs in bioanalytical chemistry. And I was originally going to sign on the dotted line with a guy named Ben Ware at Syracuse. But then somebody pointed me at Colorado State University and a gentleman named Dr. B. George Baresis at CSU. And through a friend, I got an interview. I had an interview with him where they flew me out to the university. And I decided to sign on the dotted line with CSU because George was doing some outstanding stuff. There was only one other individual who was in Germany who was doing the kind of work that Ben Ware and George were doing. And George was really innovative, and just my interest eyebrows went up when I got to know him. And so I signed on the dotted line with CSU, and now he's like another father to me. He and his wife, Deborah, who is a physiologist, they work together where George designs instrumentation and utilizes it for elucidation of biological function, but Deborah being a physiologist, reproductive and endocrinological physiologist, also used the instrumentation. So I did my PhD with George and Deborah, and so that's why I can say that my background is in bioanalytical chemistry and biophysics, because the biophysics component is the mathematical analysis that comes from all of that work.
So they really complement one another.
Oh yes,
absolutely.
They're a fine team. Yeah.
And it sounds like your roots are really kind of in academia, in some ways.
And anybody who's done a PhD plus postdoc has an academic route, definitely. So making the decision that, at one point I thought it would be part of my journey to be associated with the university as a professor. And then I looked at how long it would take for me to really make a splash in the space, and I really wanted to move into industry. However, in industry, I would probably have to shift gears significantly, which is okay. I don't mind shifting gears, but being able to carry my knowledge base somewhere where it was going to be utilized. Now, one other thing, that when I was in graduate school, I was also the machinist for my laboratory. I did a lot of machining for my lab. So when I finally signed with Hach Company, a gentleman named Joe Parrish hired me from Hach Company, wonderful guy. I came in and was able to do my own machining for my own instrumentation and things like that. So it allowed me to move along very quickly in my research programming here, because I design my own equipment, make my own equipment, test my own equipment, throw it all away and start again. So it sped the research turns, if you will, to move the research programming a little bit quicker here at Hach Company once I was finally moving well at Hach Company, once I knew the ropes.
Yeah, you brought a lot of skill sets on board that really did help kind of move you along. Yeah. And it's got to be also really rewarding to, as you said, build, utilize, break down, right? Mm-hmm.
Yeah, I was working in biology, chemistry, physics, biochem, microbiology, all at the same time, along with having design our own laser and optical instrumentation. I was blessed with the fact that I was able to practice an awful lot of fabulous mathematics and science. It's not my brilliance or anything like that. It's just that I was afforded the opportunity to play in multiple areas, which is a phenomenal gift that I was given, and I tried to parlay that into a package that was attractive to business, and somewhat I think it was, and I was able to move quickly through a lot of research here at Hach Company to move into a few pretty important pieces of work. So
we're going to talk about some of those.
Sure.
So tell me your first big project at Hach. There's a lot, I know, but maybe one that centers around some of the LDO. We've talked on that, and then also for my sake as well, just kind of explaining what that technology is.
Okay, well, I'll go back before that.
Okay.
My first real project was the development of a algae sensing system for environmental water, and it was at first based on fluorescence technology, because that was one of the best ways to go after when you measure algae, you're really measuring the chlorophyll and the chlorophyll ratio of different kinds of chlorophyll to tell you what kind of algae is there. And so because I did a lot of fluorescence spectroscopy in graduate school, I wanted to bring that forward into Hach Company for an industrial product. Unfortunately, going after fluorescence at that time really wasn't something that was that Hach Company was ready to go after. And so we actually translated into a spectrophotometric analysis or colorimetric analysis. We can get into what the differences are between those two in a little bit here. But that was the first major project that I did at Hach Company, and it had bits of fluorescence, it had bits of spectrophotometry, it had bits of chemistry development, and it was a quintessential Hach project. Simplification of a complex method down to something that any customer can use. That's the idea behind Hach Company.
And so what that takes, it seems so simple because it is simple in the end, but there's a lot of work and a lot of research and development that goes behind that to make it possible.
Absolutely. The brilliance of Clifford Hach, in addition to him being a phenomenal chemist, his ideas on simplification of process were quintessential. Those process improvements were quintessential to the success story of Hach Company. If you actually look at a laboratory prior to Clifford, just to do a hardness test, you would have had beakers and burettes and a whole bunch of chemistry equipment, probably a Bunsen burner sitting somewhere else. The only thing that was missing was a Tesla coil with the Tesla ladder with the electricity going up it. But you needed all that equipment just to do a single test for hardness. Clifford actually focused on how do I take that and make it so anybody who can read, or even better yet, anybody who can look at icons and follow the iconography to do the test. If I can develop something like that, I can really simplify the life of the customer at the wastewater facility, at the drinking water facility, or whoever wants to make these kinds of measurements, right? And so Clifford focused on that. And so the Hach 10 commandments that I'm sure that sometime in one of these podcasts we'll talk about, the basis of the basic elements of the Hach 10 commandments is simplification of complex processes down to something that anyone can do. So that's been a focus of my life and the lives of scientists, engineers, and innovators at Hach Company. That's something that we just do.
And I think it's evident that, not just evident, I think it's important to have that simplification because, again, the technology and the science behind it is so complicated. Mm-hmm. And the goal here is to make it easy, right? Make it easy so that I could walk into a laboratory and just do the test and it would be accurate. The results would be accurate. Mm-hmm. My lack of expertise didn't affect the results because the process was so clearly defined and so simple.
And if you look at the evolution of the Hach product, we went from all the beakers and all the stuff that I just mentioned to simple powder pillows where you just add some powder to a sample, swirl, do the Hach swirl with it, and then stick it into a device to read its color. That was still relatively hydraulic. And by Hach standards, if there's a way to simplify even beyond that, we should be pursuing it. So when you look at the PPA project, the portable parallel analysis system that we have, where you take a chip, stick it in an instrument, touch it to a sample of water, and it does everything for you immediately in parallel. So I could do four tests simultaneously. That is like the apex of the simplification mechanism. Same chemistry is going on is going on when I do all my burettes and all that, but in a teeny tiny package that is getting back to precision and accuracy. Anybody, a 5-year-old child can get the proper answer with that particular product.
Which is it's like people who own pools, right? Mm. You want to be able to walk out, mm-hmm. stick a test strip in the pool, mm-hmm. see, hey, am I good? Do I need to add? Do I need to take away? Mm-hmm. And having that simple, quick, because we're all busy. Mm-hmm. We've all got things that we need to be doing. And leaving the expertise and the science behind it to people like you just makes our lives so much easier.
Certainly. That's our hope.
Yeah. So I've heard that you have what you call this nerdy edge. Mm-hmm. So taking things to the nerdy edge, tell me a little bit about that.
Well, I enjoy understanding things at a very deep level. I like to understand, well, since we do wastewater at Hach Company, I like to understand why certain kinds of toilet paper are more absorbent than others. Hydrophobicity levels of the fibers that are involved in toilet paper manufacture. So that just means that you can actually take toilet paper and make it interesting from a scientific perspective. So that, to me, going to that nerdy edge is just fun. It's interesting, it's intensive. If you're with somebody who's into that kind of nerdy edge stuff, you can actually have some very deep conversations, scientific conversations that begin to move down the path of very deep chemistry, physics, mathematics on any topic. I enjoy that.
Water's the lifeblood of our communities. That's why we do what we do, to protect water quality, global water quality.
Absolutely.
It's science gives us this story that we can utilize to help plan.
Yes.
Right?
Plan or respond.
Plan and respond.
Right.
I think that's so cool. You mentioned earlier in our conversation fluorescence and colorimetry. Kind of want to go back to that.
Sure.
I know that's something that is, I've seen a lot of it in some of the professional publications, a lot of articles about it. And I'm curious, Russ, I'm curious to hear more about your role in that technology and also understanding kind of what the different, colorimetry, fluorescence, what they are and when we should use them.
Okay. Hach has made two major forays into what I'm going to call luminescence-based technologies. Luminescence covers things like fluorescence, covers things like phosphorescence, and covers things that are mathematically similar to both, but not quite either. So our first foray using luminescence-based technologies was in our creation of something called luminescence-based dissolved oxygen determination. And what is actually going on there is we have a little piece of plastic, looks like a lens, probably about 1 inch in diameter, and we coat that with a layer of what I'm going to call paint that has what's known as a lumiphore in it. It's something that when I shine light of one color on it, it gives off light of a different color. And as the concentration of oxygen in the air or in the water changes, when it's in contact, when that disc is in contact with the water or the air, as the oxygen concentration changes, the amount of the other color changes. So I'm shining, in the case of LDO, luminescence-based dissolved oxygen Hach product, I shine blue light on the sensor, red light is given off. And as the oxygen concentration increases, the amount of red light goes down. So it's an inverse relationship physics reaction. And we have developed the electronics and the math and the chemistry to produce a product that actually is widely used in wastewater determination of oxygen. And what you may or may not know is that aeration, or pumping oxygen into a wastewater pond at a wastewater facility, is one of the most expensive things that they do. So optimal management of that through measurement and control is one of the most important things that you can do. So this particular sensor is absolutely required to manage that oxygen relationship in a wastewater pond. And we developed that technology began working on it in 1997, and had a product, I believe, and I'm talking brainchild idea of a product out to something tangible in the hand in about 5 years, I believe it was.
Wow.
And that seems long, but in actuality, it was a brand new paradigm to Hach Company, something we've never done before. And it was exceedingly innovative back then. It's not particularly innovative now, because a lot of people do it. At the time, it was disruptive, breakthrough, whatever you want to call it. But that was the first foray into luminescence-based technologies at Hach Company.
And the math behind that had to have been extraordinary. And so tell me a little bit. I heard there was a dream.
When we were developing LDO, getting signals out and the electronics and the hardware, they were challenging. Development of that was challenging. A number of fine engineers, fine scientists worked on this project and really knocked it out of the park with respect to the device itself and the device architecture. But transforming those signals into a real oxygen value was a challenge, and extreme challenge. And there was one particular piece of math that was missing, and I couldn't for the life, and at that time I was a lead scientist on this. I could not for the life of me fathom how I was going to make this particular transformation. And it's something that I had been ruminating on for probably weeks, painfully so, to where you wake up in the middle of the night in a cold sweat because you don't know the answer yet. Well, one night I woke up in a cold sweat with the answer, jumped out of bed, wrote it down, and then got up the next morning and realized that it wasn't doggerel. It was actually the solution, and it now is utilized in the system that we have today. But it came out of a dream, and it was quite scary because if I hadn't had that dream, we would have had to go some other route. I'm sure we would have found the answer, but it would have been a longer
Did you write down what you ate before you went to dinner, or any of the things that happened prior to that? Because I could use that in some of my questions that I have. I need that Russ dream technology.
It was multiple nights of fear and trembling, lots of discussions with other people. I'm not going to take full credit for this. I'm going to say that I had fabulous conversations with other engineers and scientists, but the final packaging and how to put it together came in a dream.
So fascinating. The collaboration came together in a dream, and you had the answer.
The weird part is that I have dreams like that. In colorimetry or spectrophotometry, what I'm doing is it's what I'll call a 180-degree technology. I'm going to shine, yada, yada, yada. I'm going to shine a light into my eyeball, and then I'm going to put something in front of it that has a bit of color associated with it, and I'm going to tell you how much color is in that sample.
Okay. Right?
Now, what that means is I have an exceedingly intense beam of light coming at my eyeball. I'm looking at the sun, trying to tell you exactly how red a red filter is. Well, that's a great way to do chemistry, to ascertain the quantitation in chemistry, which is exactly what many of the Hach products do. Brilliant science, but it has some limitations with respect to detection limit and management of the intensities of the light that are coming off. If I have too much color in that sample, I won't see anything. It'll be completely black. If I have just a teeny tiny bit, how do I discern between the blinding bright light and the teeny tiny bit of color change that I'm going to have? Okay, so it works within a range.
Sure.
Now, the wonderful thing about fluorescence-based technologies applied in the same use model is that fluorescence is classically, or luminescence are classically considered 90-degree technologies. Blah, blah, blah. Let's take a look. Instead of looking at the beam coming straight at my eyeball, I'm going to shine the beam 90 degrees from where my eyeball is looking. I'm going to shine my beam into a sample, and I'm going to look at what color or what light scatters back to my eyeball. Now, the difference between this and the colorimetric method is that in a black room, I can have, if I have any kind of event, a fluorescent event at my thumb, shining a beam this way, I'm going to see it this way.
Coming towards you.
Coming toward me at 90 degrees. I will see that, and it will have a very, very low background, as opposed to shining a sunbeam at my eyeball and then trying to, as I'm screaming from my retina being burned, actually trying to discern the color change. With fluorescence, shining a bright light, I never see the bright light necessarily. If I'm doing a good job of fluorescence detection, I only see the emitted light from the sample. Now, what does that mean? Why would I care? Well, in generalized thinking about fluorescence versus spectrophotometric measurement, your detection limits go down. Okay. So I have a a very low detection limit with fluorometric methods as opposed to colorimetric or spectrophotometric methods. So Hach company has really done a fabulous job of pushing the boundaries of spectrophotometry. But there is a floor. You can go so low and then you can't do any more. Fluorescence takes you to the next level down.
It's the basement. It's where you go down below even maybe the basement.
And we don't know what the basement is for the kinds of measurements that we would do. Your instrument, with spectrophotometry, we are instrument bound. We push the instrument to the absolute apex of its performance. With fluorescence, we haven't even scratched the earth yet.
So we know the limits.
Right.
Spectrophotometry.
Or colorimeter.
Colorimeter. But with fluorescence, we don't know what the bounds are yet.
Well, excuse me. We don't know what our instrumental bounds are, how far Hach can push that. We have just started, we're now selling a new product that is for chlorine determination at ultra low levels, that's based on a fluorometric method that looks from a customer use model perspective identical to our classical Hach simplified methods, where I pour some powder pillow into a sample, do the Hach swirl, and then stick it into an instrument and read it. But now we're using spectrofluorimetry instead of spectrocolorimetry or spectrophotometry.
So it really depends on what measurement you're wanting to do, what you're wanting to measure, at what level you're wanting to measure with the science that you use, the technology. But tell me more about the chemistries.
Yeah, as I mentioned, the instrumentation is something that Hach does really well already. We knew that we could do, we could think about instrumentation and we could think about how to develop this kind of 90-degree technology or acquire that technology. We knew that we could do that. The trick is making chemistries that resemble the use model of the current customer base with spectrophotometric chemistries, but making them work using fluorescence as the finish. And I want to really herald the chemistry team here at Hach, because in reality, some people aren't going to like this, but Hach is a chemistry company. We develop chemistry for water, and we use instrumentation to look at that chemistry and how it changes with different analytes of interest in the water. But the development of those chemistries is paramount to our success. And so the chemists here at Hach Company, led by a gentleman named Darren McFarland, who is the director of chemistry global director of chemistry for Hach Company, he and his team have done a phenomenal job of thinking about, okay, we've seen the detection limit for spectrophotometry here. We know that we'd like to go lower. Now we need to develop some fluorometric assays that will go lower in these particular analytes that I'm not going to tell you about because they're things that are in the works. But the chlorine one is something that we did, and this is how it came about. Darren said, I want to go lower. And so he had to develop chemistries that were based on fluorometric analysis. Now, there are some intricacies with fluorometric analysis. You have to keep things in the dark so they don't get destroyed by the light. You have to work in a little bit different manner with respect to interferences.
Okay.
And so that team has done some phenomenal work in capturing all of the nuances of fluorometric chemistry while maintaining the performance in all sorts of, in our classical use models. So these chemistries have to work in the current use models and in the current samples that the customer needs to use them in. And that is one of the most important pieces of the Hach success story, is we do phenomenal chemistry in whatever we do. And we simplify that chemistry down to the point where the customer doesn't even understand how complex it is.
That's really cool. And you're talking about pushing limits. So is there anything that you see coming in the future that you can talk about that you're excited about? Exciting new analytical methods? Any new fun?
There are boatloads of fun things that we're working on that are disruptive to the space and will impact the market in a positive manner. And I would love to tell you all about them.
But you can't.
But I can't.
Yeah. Trade secret, right?
At this time, until it's a product, I cannot tell you. I cannot share.
But I'm telling you, the stuff that you've told me thus far, and how the technology has changed, and how Hach is continually pushing the limits, and how scientists like you are thinking ahead and really looking to the future and saying, where do we need to be? And what is it going to take to get us there? And understanding, because you mentioned limits, and I know that parameters are changing for wastewater utilities very rapidly. What would you tell someone? What would you tell someone who maybe is fresh out of college and they're interested in the water industry and they want to stay relevant? They want to continue down the path to being the next Russ Young.
Well, this is going to sound antithetical to what you're probably expecting. The customer, in reality, doesn't want analytical methods. The customer wants solutions that make his or her life easier. They don't care. If the solution works, they don't care. So always, if I had one piece of information to give somebody who's a burgeoning technologist or innovator, generalized innovator, and that includes the marketing side, what would I tell them to do? Find out what the customer needs, or find out what the customer thinks they need. Monitor their process closely. Learn what they do. Learn what they complain about. Learn what they think can't be done. And then do it. Give them solutions that help them with their problems that they haven't even thought they have. But in essence, in reality, they do have. They just didn't know there was a solution, right? So it's all about gathering the proper insights from the customer's daily work, from the customer's buying habits, from the customer's problem set. Then sitting down with innovators from all areas of the business, and some that aren't a part of the business, because adjacency is one of your best friends. Because thinking about something in an adjacent manner often leads to fabulous solutions, right? It's about orthogonal thinking at the end of the day, thinking off axis about the problem that the customer has. Being willing to step outside your normal solution paradigms to go after the solution that nobody ever thought about because it can't be done.
Breaking outside of that box, taking what you've been told, like you said, can't happen, and saying, but how can it?
But how can it happen?
But how can it happen? And it also brings up, you were mentioning the simplicity, and there's a term that is used at Hach. Hachification?
Absolutely, hachification. Providing the customer with a simple solution to their problem.
That's awesome.
That's what we do.
Well, that's a very good point. I appreciate that. I think we hit on a lot of really important topics that people are talking about. We got to know you a little bit better. And I look forward, we talked about maybe talking about the Hach 10 Commandments.
Absolutely.
At some point. And we learned how a dreamt a solution.
Dreams come true.
Dreams come true. Thank you so much. I appreciate you.